Good morning.
Morning.
How are you?
Good.
I like that about you right now. Me too. I could not sleep. I slept in too late on Sunday and paid for it by not being able to go to bed. Huh? Whew. Where's your peeps? All right. Good morning.
Good morning.
Shall we do this? Happy Monday. How we doing? Did you have a good weekend? All right, well, I'm Tony Farrar from the Mechanical Engineering Department, and today I'm going to show you how to fake your data. So, let's see, where did I start? Friendly reminder, today, phase 1 of the project is due, and we're starting phase 2. If you did not complete the prerequisite assignments for eligibility, today is eligibility cutoff for phase 2. So get caught up if you haven't yet. By the way, that's already an extension. It used to be last Friday. So you should be done with all of these things. Today we're going to talk about spoofing data and a little bit with symmetric matrices. Wednesday we're going to revisit flow control because it's a pretty critical topic for most of your projects. And then we'll do another code sprint on that on Friday. So just a reminder, cutoff for phase 2 is tonight. Get done with that stuff. A further reminder, cutoff for phase 3 is Friday. They're all supposed to be Friday, but we gave you a couple extra days on the first 2. We're done there. So, bottom line is, you should be done with these things weeks ago at this point. Certainly get there fast. We have all kinds of ways to support you, like people up in the library, and a fancy-dancy email address that gets back to you in lightning record speed, unlike any other professor on the planet. Well, maybe not. Any questions? Policies, cutoffs, etc. How's phase 1 going? Feeling good? 2 heads going up and down and a whole lot of blank stares. Not sure if those are dagger stares or we're not awake stares, but either way. So what I wanted to talk about today, very briefly, is how to spoof some data. One of the jobs in phase 1 was to identify the core function that your code does. What's the main thing? So for example, maybe we're making a social app. The main thing that this social app does is match you with suggested new friends. That's what we want you to do for phase 2. We want you to write the code that does that part, whatever your fancy algorithm is for taking people's information and helping them find new buddies. The parts that you would need to make this actually usable would be an input, right? You list all your current friends, maybe your favorite movie and band and class schedules and things like that. And then eventually, after it crunches through this algorithm that you've created during phase 2, you would want to print that so that the person could find their new friends. And you could imagine something like a social network might give you a bunch of pictures of these people and links that you can press to instantly invite them to be your buddy or whatever. That's nice. That's all GUI stuff. So when it comes to putting the input in and getting the output out, for now, don't worry about it. Right now, I just want you to write this piece right here in the middle, the main code that if it had the data, it could produce the output you want it to. And so what you would do is just hard code this stuff into the top of your code. As you're writing your program, just declare variables and fill it with all the information that somebody would have typed in. And when you're done, instead of printing it to some fancy GUI, just spit it out to the console, and eventually you'll teach your program how to print that in a more user-friendly and digestible way. I'm going to give you an example of this right now, of what I mean by hard coding it into your code for now, and eventually you'll have to write a new function that goes and gets user input. Maybe they would type it in using an interface. The benefit of writing your code this way is that you don't get stuck up on what should the input look like. Because the truth is, what the input should look like is whatever's optimum to make your function work as easily as possible. So you could write your code and pretend like maybe the first time through we just used a simple list for our input. Well, I could just type all that in, maybe I'll make a dozen users out in my mind and I'll just type that in at the top of my code. And then as I start writing my function, I discover that that list is really inefficient and really inconvenient to do anything with. Well, that tells me I could go back and change my spoof data type. Maybe I'll make it a dictionary, which is a little bit more complicated data type that lets you look things up easier. And so you can iterate on this a few times before you ever write the code that actually starts asking the user for input. And the beauty of that is, by the time you design your input command or your input GUI, you will have really optimized how that data is going to be stored as somebody types it in, realized all the holes and things, so you don't have to go through the GUI process once. Questions on that? Would you like to see an example? Of course you would. So we're going to do an example together. We're going to create a symmetric matrix today. It's going to be a really quick code challenge. Grab a piece of paper. I want to collect these again like we did a few weeks ago and just see where we're at in terms of our logic. We're going to do the similar thing. We'll work on it a couple minutes alone, see where we end up. The way this works, we're going to make a symmetric matrix. What a symmetric matrix is here's the diagonal. Okay? So you've got numbers going down a diagonal. And then up above the diagonal, we have these numbers here. 13, 8, 67, 42, 19, and 23. What a symmetric matrix does is takes these values and mirrors them about this diagonal. So if I'm going to mirror this value about the diagonal, what number goes right there? A 13. What number goes right here? A 67. So here's my fancy color-coordinated example for you. I'm not sure if this makes things worse or better. Worse. But what we're doing is we're taking that number and putting it there. We're taking that number and mirroring it there. This number goes here. This number goes here. Here to here. Here to here. So basically, everything that is above the diagonal gets flipped over and put below the diagonal. That's going to be your challenge here. Let me switch over and give you the setup. So I'm going to give you this bit of code. Is the font big enough, back row? No? This again. Why does it do that?
Like the red circle.
Huh?
Bam.
Yeah, except it didn't apply it.
Oh. I tried.
92. Enter? Yeah, but I can't see if I've gotten there. No. That's what I'm doing right now. It's just texting in here. I apologize, back row. Tune into the live stream and you'll get a very nice big picture of it. That's as big as we get today. All right, so somebody tell me real quick, what did I do here? What's this top line doing? Import NumPy as NP. What is that? I'm sorry? It's what? Right, I brought in an extra collection of commands. There's this thing called NumPy, and it's got a whole bunch of extra built-in features that basic Python doesn't have. And I imported it as np because anytime I want to use a command from NumPy, I have to type the word numpy dot and then a command. Say, for instance, this zeros44 command. By importing it as np, I can type np instead of numpy. It's just to make it a little bit shorter, a little easier to use. What do you think this command does? It's not a trick. Yeah. Fills an array with zeros. How big is this array? Huh? 4 by 4. All right, let's just comment these out for half a second and take a look at what that did. So I'm going to run this, run module, and we'll flip over here, and there is a 4 by 4 array filled with zeros, just like we predicted. Cool. All right, so now I'm going to use this command. You'll remember I'm trying to take this, that is terrible to look at. I'm trying to take this and build it in Python right now. And so this command here, what do you think it's doing? Sets the first row, right? Row 0, this colon here can be read as all columns is equal to, and then I gave it a row vector, 1, 13, 8, 67. It's going to take that and paste it across that top row. So if I run this, you'll see that I've taken 1, 13, 8, 67 and pasted it across the top row right there. And so I've taken the liberty of typing these other rows in for you so that you don't have to worry about it. This is the second row, index 1, all columns. The third row, index 2, all columns, and the fourth row. And so if I save this and I run it, we now have this upper triangle matrix is what this is called. 1, 13, 8, 67, 0, 2, 42, 19, 0, 0, 3, 23, 0, 0, 0, 4. And what I want to do is I want to fill the zeros below the diagonal here with their mirror image from above the diagonal. So I want to take the 13 and stick it right there. I want to take the 8 and stick it right there. And so on until I fill in this whole lower triangle. So the 42, the 67, the 23, and so on. Questions on what I'm asking you to do? Are you clear on what I'm asking you to do? So right now, what I'd like you to do is write the code that fills those in. But I don't want you to do it. What I've done here, by the way, this is a perfect example of spoofing the data. We could write this in a way that gives us a function that, given any matrix, copies values over the diagonal. For now, I'm forcing it to be this matrix. That's spoofing the data. That's creating a test pit of data to see if our code works. So what I'd like you to do right here is take a few minutes, and I want you to write the code that replaces all these zeros with their mirror image value, but I want you to write it in a way that it would work for any matrix, not just for this one. All right, so I don't have a timer prepared for you, but I can grab one really quick. Let's take 2 minutes on our own and see how far we get. Starting now. That's in the way, isn't it? There's the code. Put that down. Oh, that didn't work out. All right. 2 minutes. I'll give you a warning. Good morning. How are you?
Well, how's everything?
I'm good. Having fun.
Use people with NumPy.
I did? Okay.
Just because the way Python normally does indices is 2 brackets, whereas NumPy lets you get away.
Ah, okay. Yep. Uh-huh. Okay. That's the challenge. Right? How about I give the whole class a hint and it might help? Who wants a hint? Okay. What are the indices of the 13? Row 0, column 1. What are the indices of the 8? Row 0, column 2. Okay, so here I have a 0, 1, are the indices of this one. That's a 13, and I want it to go there. What are the indices of the 0 slot that I want to put that 13 into? 1, 0. So the coordinates of this 13 are 0, 1. The coordinates of the place that I want to replace are 1, 0. How about the 42 here? What are the coordinates of this 42? Row 1, column 0, 1, 2. So that's a 1, 2. And I want to put it right there, which is row 0, 1, 2, column 0, 1. Do you see what's happening to the indices? Write out the address of a couple and write out the address of where you want it to end up and see if you don't notice a pattern. Let's take another minute to brainstorm. When it clicks over to 10:20, I'll give you the answer. All right. Who thinks they have it? Got a couple hands. Get excited. How'd you do it? Huh? Or just give me the basic idea. Uh-huh. Created two variables, A and B. Okay. You'd use nested for loops. Okay. Uh-huh. So you swapped the indices. Interesting. All right, everybody that wrote something down, put your name on the piece of paper, pass it to an aisle, then I'll give you the answer. Write your name on it, tear it out, turn it in. Write your name out, tear it out, turn it in. Right now. I should hear papers flying. Everybody's saying, wait, my name? What? Quickly, 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 to the rows, to the aisles, and then down front. Pass them down, pass them down, pass them down. I should see stacks of paper flowing down row by row all the way to the front of the room. Collect them, pass them in. Collect them, pass them in. Go, 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 go. Wake up and move. Yep. Pass them forward, pass them forward. Let's go. Think fast thoughts. Parallel processing. More than one thing moving at once. The other kind of quickly. In 5 seconds, I'm done collecting. 5, 4, 3, 2, 1. Papers up. Whoever's holding papers, hold them up. Here we go. Everybody that played along and was kind enough to turn your work in, extra credit. Woo! Yeah, it's April 2nd. I really am going to give you credit. Thanks. Woo. Okay, so check this out. Back with me. If we look, we want to take this 13 and put it in this 0. The current address of the 13 is 0, 1. And where do I want to stick that? I want to stick it in 1, 0. The next item that I want to grab is this 8. What's the address of that 8? What's the address of the 8? Huh? 0, 2. And where do I want to put it? 2, 0. How about the 67? I want to put the 67 here, which is 3, 0. And I want to take it from x of 0, 3. Do you see how the indices are switching? What's up?
Did you write a general code to do all this?
Oh yeah, I'm just showing you where it came from. Let's look at the 42 as the last example. The 42 is currently sitting in row 1, column 0, 1, 2. 1, 2. And I want to put that where? In 2, 1. Like so. Hopefully you're starting to see a repeating pattern here. What happened to the items on the diagonal? You don't have to handle them, but does this screw anything up? Have I screwed anything up by adding the ones on the diagonal? And so what you can see here is the thing that goes 0, 1, 2, 3 with all zeros, and then we just flip them. Well, we could write a general code to do that pretty quick, right? For I in range 4, for j in range 4, x of I j, ji is equal to x of I j, and print it to see if we got it right. And I'm just going to comment these out so you can see where it came from. Save it. Run it. Ba-ba-ba. There's your general code. General code. Questions? Yeah. I'm sorry? Which numbers? The random numbers in here? I made them up. Yeah. Yeah, I took the code above, which started with a bunch of zeros down here, and I wrote this piece of code that could take any matrix and flip it about its diagonal and print the whole thing out. If I were to change some of these numbers, say this 42 to a 3000, whatever the heck that is, and run it, it'll still work. It's just that now it's going to print in scientific notation because I did it with a big number. So that didn't work out quite like I hoped. How about just 345? There we go. You can see, so it still works with any code. So now, presumably, if this were your project, this is the bit that I want you to turn in this week. And this is the bit that you get to fake, but eventually you can ask for extra input from the user. How the heck that printed out, I don't know. Right? Are you clear on what I'm asking you to do this week? This is the part that you can make up for now and eventually. So this could be defining a bunch of user data. And you just type it in there for now. Ultimately, your app's going to have to go get that from somewhere, but not today. Today, I want you to write this part that processes that data for different inputs. Don't worry, I'll paste this code so you can take a look. So just a reminder, this is what's due tonight. Value proposition statement, minimum viable product. I want a feature list. Identify the most important one because that's your coding assignment for next week. Paper prototype is a stack of papers that you could hand to somebody and they could run your app. I've been working on that. And lastly, a non-functional GUI layout. I want this done on a computer. So if you're doing Android and iOS, drag and drop in the studio. If you're doing a web app, drag and drop in any program that draws pictures. I find PowerPoint to be very friendly for these types of things and suggest it. Next week, you're going to code the core feature with spoofed data. We're going to skip the GUI for next week. Just write the main code. Just get that working. Input and output from the console only. Give me 30 more seconds here, y'all. Yeah. Yep. I want them again in the report, revised, whatever. The question was about the value proposition. Sorry. Yes, even if you already turned it in, give it to me again. Yeah. How do you want it submitted? Like one person? One person in the group submits it as a single PDF file. How do you want the names on it? Anybody that contributed to it, put your name on the front page. We'll be good to go. Yeah. On Canvas, it doesn't look like there's somewhere to actually create a submission. You can save things, but there's not actually. We'll double check that. We'll make sure that there's a place on Canvas to submit it. If not, if you run into any submission issues, email it to codehelp@temple.edu. There's your backup. It is due at 11:59 whether you can figure out how Canvas works or not. Phase 3 will be revisions, bells and whistles, GUI working, things like that. And Phase 4 will be the full demo. Once again, Phase 2's deadline is a week from today. One submission, PDF. It should be going in on Canvas. We'll make sure that you have a place to submit it there. If you run into trouble, you may email it to us. These are the things you'll be working on for Phase 2. By a show of hands, do you want me to show the list for Phase 2 or Phase 1 as I give you the rest of the class period to work? Phase 1. Phase 2. There's a lot of non-votes. Phase 1. Phase 2. Sorry, Phase 2. All right, we're going to display Phase 1. I'll give you the rest of the day to work together to make it happen. Thanks, everybody. Okay. Yep. Just a second here. Let me kill my streams. Bye, everybody. Thanks for tuning in.